Hello and welcome to Calculus Tutorial. We again have some new derivatives and integrals to add to our repertoire. And so here are the three that we're going to look at. Two new derivatives, the derivative of a to the x and the derivative of log base a to the x. They should look a little familiar, just slightly different, because we know the derivative of e to the x. Now we have to do a to the x. And the derivative down here that we know that's similar is the natural log of x. So we're going to do a regular log of any base of x. And our new antiderivative, we know the antiderivative of e to the x, but what if it's not an e? So any number a to the x is what we're going to take a look at. So let's do our derivatives first and see what they are. So first, what is the derivative of a to the x? Well, I want to compare this to e to the x because that's the one we already know. And it doesn't change, it's just e to the x. So this one will be similar. It is basically going to stay a to the x. But because we don't have an e as our base, we have any other number, we do have to add a natural log of a in front of it. You can put that in parentheses if you want, but you have to multiply by the natural log of a. Natural log of a times a to the x. So let's use that. I've got a product rule here for us to take a look at. So we take the derivative of the first, negative sign, times the second, 5 to the x, plus the derivative of the second, so that we are going to use our new rule. So that will be the natural log of the base, which is 5, times 5 to the x, times cosine, the first. Alright, so what can we factor here? They both have a 5 to the x. So it looks like we can factor out that 5 to the x. And we always like to put subtraction second, so I'm going to put the minus sign of x over here. And this one is positive. We took out the 5 to the x, so there is a natural log of 5 times cosine. So that is our derivative, how it can fit into a product rule. But right here, this is the new part that we had not done before. Just that piece. So the actual derivative there is not too difficult. Alright, one more derivative here. What is the derivative of a regular log base a? Well, let's compare that to the log derivative that we already know. We know the derivative of the natural log of x. Learned it a little while ago. That is 1 over x. So yes, this one will also basically stay 1 over x because it's still a log. But because our base is not e, this has a base of e, we do have to add a little bit. It's very similar to this one, only it's in the denominator where we have to put the natural log of a. Alright? So very similar to our other one, but because we don't have an e that makes things work out nicely, we still have that natural log of a. Alright, so I got us a nice big derivative to try that is a double chain rule. So we definitely have something inside of our log, but if you take a look, this whole log is being raised to the 5th power. So one way to think about that is like this. We have log base 3 of 4x squared minus 3x, all to the power of 5. So our first outside is the 5th power, then our next outside is the log, and then finally our inside is this polynomial. So the derivative of the outside, the 5 multiplies down, the inside stays the same, and that becomes a 4. Our inside is log base 3 of 4x squared minus 3x. So now we have to multiply by the derivative of the inside, which is the log. So this is going to be the new thing, taking the derivative of a log base 3. Well, it is basically going to be 1 over the inside, which is 4x squared minus 3x. But because it wasn't a natural log, we have to add the natural log of the base in front here. It just multiplies the natural log of 3 times the derivative of the inside, which is the derivative of this, which will be 8x minus 3. Really long, but that's how it works. And again, the only new part was this piece right here. The rest was just chain rule. But when you take the derivative of that log, it's not just 1 over x. You have to have that natural log of 3. It has to do with the base change property for logs. Not too important to us right now, if we can remember these rules. So those are our derivative rules. We have one antiderivative rule to take a look at. And it is the antiderivative of a to the x, which looks very similar to a nice, easy one that we already know. We know the antiderivative of e to the x dx is just equal to e to the x plus c. So yes, this one will be almost just a to the x. But we're not quite that lucky because the base is not an e. In front of it, you have to add a 1 over the natural log of a. That fixes it. Again, it's a base change property kind of thing that is happening. And don't forget your plus c. So let's take a look at this antiderivative. I chose a fairly easy one for us. But make sure you can see the difference between this term and this term. All right, x to the 5th is just going to be a power rule. 1 over 6 times x to the 6th. That is a power rule. This one is now our exponential rule, a to the x. So it just matters, is your x the base or is your x the exponent? Definitely changes how you take the antiderivative. So this will basically just stay 5 to the x. But because that base is not an e, you have to add a 1 over natural log of 5 in front. All right, so that's not too bad. The hardest part is seeing the difference between those two functions. Maybe not right now, but in a couple of weeks, it'll be really easy to get those two confused. All right, so we've got two new derivatives and one new antiderivative that we are looking at. Again, I'm hoping you can see how these are similar to ones we already know. That one is very similar to the derivative of e to the x. This one is very similar to the natural log, and this one is also very similar to the antiderivative of e to the x. So start there, and hopefully you can figure out where the extra natural log fits in. This one is in the top, this one is in the bottom, and that one is also in the bottom.